Today's talk is about replacing milk protein with rapeseed and or rice protein concentrate. It's a study on growth and growth biomarkers in piglets. The background for this study was that, according to FAO, the demand for protein will increase with 50 to 80% over the next decade due to the increase in population. And replacing animal protein with high-quality plant protein can keep the increase of the protein in the lower end. So, this growth experiment with the piglets, we had the following hypothesis. That was rapeseed and rice protein can replace milk protein when adjusted for digestible amino acid composition. And we made 4 dietary groups. One group was rapeseed protein called Isolex from a Turtex company. And then we used rice, Remopro, in 80 with 80% protein. And then as the milk protein, we had MCP from former Quick, it's 85% protein content. And we made the diets with the equal amount of a standard digestible crude protein in all diets, and recipes was based on the content of digestible crude protein in the ingredients from the protein isolates, and then we supplemented with the first 4 limiting amino acids, lysine, methionine, threonine, and tryptophan, in order to the piglets' need. So in theory, all piglets should have, all diets should provide the same amount of amino acids and the same amount for energy to the piglets, so they should in theory grow the same. Looking a little bit more on the composition of the diet, we can see we had the grain mixture, which of course the major part of it, and then we had with the rice protein isolate and the rapeseed protein isolate, we had an equal amount of them that had pure plant-based protein here in this diet here, and then we had the second diet, which was a combination of milk protein and rice protein, also 50-50%, and the third diet was a milk protein and rapeseed protein, and then we had the fourth kind of control diet, which was the pure milk-based protein diet. And as you can see in the bottom, we adjusted with the necessary amino acids for the different diet. If you look at the dietary amino acids content, you can see here it looks like we have a higher content of methionine in the milk-based diet, but that was just in order to compensate for the low cysteine content which is available in milk. So when we added methionine and cysteine together, they were all at the same level. The same was true for lysine, threonine, and also for tryptophan. The experimental setup, we used a total of 96 piglets, which were randomized and housed in pairs, male and female. So we had one male and female in each pen, so we used 48 pens. And with the number of piglets, we allowed us to make 12 replicates per treatment. The piglets, they were weaned at the normal age of 28 days, and then we had them on a standard diet for 2 weeks, and then we got them and distributed them into the different diets and into the pens, and started the experiment at day 0. And then we wait every week until 3 weeks after the start of the experiment. We weighed them once a week, and we recorded the feed intake also. And then on day 22 and 33, we removed 1 pig per pen, and we gave them a fixed amount of feed just 1 hour before we euthanized them and took out blood samples and organs, liver, and all the muscle tissues we should use for the measurements. The sampling and the analysis we made was course, we had the pen as an experimental unit with respect to feed intake, body weight, gain per day, and feed conversion ratio. And we had the pig as an experimental unit with respect to body weight, organ weights, and also a measurement of the bones, the second and the third metacarpal. And with respect to the blood samples, we also had the pig as an experiment. We had 12 repetitions, and we measured glucose, insulin, growth factors, EGF1, plasma-urea, amino acids, and from the liver samples we took some to gene expression and protein expression. Also for some muscle samples we took out for gene expression. Going to the results, what we could see was that we had a higher body weight at the end of the experiment on the milk-fed pigs and the milk and rice-fed pigs, whereas the combination with milk and rapeseed protein and rice protein, they show a significantly lower final weight. This was also reflected in the length and the weight of the second and the third metacarpal, where we could see generally with increasing milk, the pure plant-based diet with rape and rice was at the lowest length and also the lowest weight of the metacarpal, and the pure milk-based diet has the highest weight. So it was not just a question about there were more fat, there were also simply higher in the growth rate. Feed efficiency from week 1 to 3, where we had the daily gain, was increased again as reflected we saw before with the final weight. We had a higher daily gain when we had the more milk we put in the diet, and also the feed intake was the same. We had a little bit pure plant-based, rice and rape lowest, and pure milk and rice was the highest. So this was reflected also in the feed conversion rate, where we had a higher feed conversion rate with the higher content of milk we had in the diet, and the one with rapeseed and rice was the lowest. Looking at the plasma parameters, at the glucose there was no significant difference. Also insulin, there was no significant difference. The growth factor IGF-1 showed also no significant difference. Plasma-urea, there was also no significant difference. So there was nothing of these growth parameters where we can say they were had and could explain the difference in growth. Looking at the indispensable amino acids in the plasma, we could also see here that generally there was a rice and rape seed had the lowest content of indispensable amino acid in the plasma, whereas when we had the milk-based, especially milk and rice, and the pure milk, they had the highest content of indispensable amino acids in the diet, in the plasma. And with respect for the dispensable amino acid, it was true for 3 of them also. Here we had the asparagine, the proline, serine, and tyrosine as well. To further try to come up with an explanation, we made some gene expression, and we selected some genes which were related to pathways. That were related to growth, protein metabolism, and of course with the growth hormone, insulin, and growth factor for protein synthesis. And you can study these sequences afterwards. But what we saw when we were looking at the different liver genes we measured the expression on, there was no significant difference between these growth factors. Also, this was the same true for the muscle gene expression. There was no significant difference in any of these growth factors. So it was not able to explain it in that way. What Then we measured also the hydrolysis rate of the protein, which you can say that's in way to measure in vitro speed of digestibility. The faster the degree of hydrolysis is, the more fast we believe, especially if you have enzymatic deficiency in the digestive tract, it can be rather important. And what we can see from here is that when we have the pure milk protein concentrate had the highest degree of hydrolysis, high speed of digestibility, followed by the combination of milk protein concentrate and rice, and with milk protein concentrate and rapeseed on the third, and the pure plant-based rice and rapeseed with the lowest speed of digestibility. So what we conclude from this study is that milk concentrate protein and rapeseed and rice and rape diets, they gave a lower growth and higher feed to gain ratio than pure milk concentrate and milk concentrate together with rice diets. No effects at all were seen on the postprandial glucose, insulin, and IGF and plasma urea levels. And for all indispensable amino acids, except cysteine, the plasma content was lower in the plant-based diet versus 100% milk-based diet, even for the supplemented amino acids. A similar trend was seen for 3 out of 8 of the dispensable amino acids. Expression of genes related to growth and protein metabolism was not significantly affected by dietary interventions. And MCP has the highest hydrolysis rate, followed by MCP plus rice, greater than MCP plus rape, which again was faster than rape plus rice. So overall, we conclude that it's challenging to substitute milk protein with plant protein concentrates. Thank my colleagues and the different funding bodies, and thank you for listening.